Okay, a rancher has 360 yards to fence, a fence to enclose a rectangular pasture. So we have some rectangular region, and it's going to be 360 yards to go all the way around and fence it. And the area, the pasture should be 8,000 square rods in area. So we know the area is 8,000 square yards. And if the fencing goes all the way around, then that must be the perimeter, 360 yards. What should its dimensions be? So we have restrictions. The area has to be this much and the perimeter has to be this much. So I'm going to go ahead and call this guy x the width, and we can go ahead and call y the length if we want to. So the perimeter is going to be 2x plus 2y. And we know that's a 360 equals 2x plus 2y. That's one equation that has two unknowns. Remember, an equation that has two unknowns is going to need another equation that has the same unknowns. So maybe I can use the area information to my advantage. So area is length times width, which is x times y in this case. And then I know the number is 8,000 square yards, which is equal to xy. So I have two equations, two unknowns. What I'm going to do is I'm going to use this to find what y should be, and that's going to be 360 minus 2x equals 2y. Let's divide everybody by 2. That's going to be y equals 180 minus x, and then I'm just going to go ahead and substitute this into that y. So basically similar to what we did in the notes, I have area's length times width, and I want both the length and the width to be in terms of the same variable, so I just use the perimeter equation to my advantage to do that. So basically what I have now is 8,000 square yards is my area, width is x, and length is this guy right here, 180 minus x, which gives me a quadratic equation if I distribute the x. And quadratic equations, we try to set them equal to 0 and see if we can factor. So I'm going to subtract 8,000 from both sides, and that's going to be negative 8,000. And then I have the 180x, and then the minus x squared. And again, I kind of don't like the minus x squared, so I'm just going to divide, either move everybody to this side by adding it, or divide everybody by a negative 1. That's also allowed since it's an equation. So 0 equals a positive 8,000 minus 180x plus x squared. Now that looks a little bit better. X squared minus 180x plus 8,000 equals 0. So that's going to factor into x and x. And two numbers that multiply to 8,000 and give me a sum of negative 180. If I go through my list, 80 times 100 would give me 8,000, and both have to be negative to give me the negative 180. So minus 80 minus 100. And I'm going to pop out the two answers. So x is either 80 or x is equal to 100, which implies that my rectangle was, remember it was x and this was y, and we knew that y was up here 180 minus x. So y is 180 minus x, and if I know that that's 80, let's get the y value, which is 100. Or if the x is 100, you'll notice like we did in class, it just gives you the same value. 180 minus 100 gives me 80 anyway. So bottom line is, it doesn't matter whether I look at it like this, or maybe I look at it like that. It's really either 100 by 80 in this case. This would be 100 yards, and this would be 80 yards. Or if you want to look at it flipped the other way, the y value would be 80 yards. And the width, or this region, would be the x we found, which is 100 yards. Either way, you get the same answer of 8,000 square yards, with covering the whole thing having 360 yards. So basically the dimensions, easy way to say it is, dimensions are basically 80 yards by 100 yards. And again, remember what we did. We used the information to come up with two ideas, one for the perimeter restriction that was given, one for the area restriction that was given. And since we had two equations, two unknowns, we were able to find both x and y just by doing a substitution. Isolate y in one of them, plug it into the other one, and once we did that, we got an equation that was quadratic, and in the process we found the solutions of the quadratic equation that led to the dimensions of the rectangular region.